So we're going to keep graphing quadratics, but this time we're going to use something called vertex form. So by the end of this lesson, you should be able to find the vertex of a quadratic function when it's in that form, and then graph one by finding the vertex and other critical points. So not every quadratic function can be factored. The ones I've given you so far all can be. But if it can't be factored, we need a different way to graph it. So the way that we're going to do that is by having something in vertex form. And it looks like this: y equals a times, some parentheses, x minus h all squared plus k. Your vertex is h comma k. Your axis of symmetry is x equals h. And then the a tells you your direction. Remember, if a is greater than 0, it goes up, and if a is less than 0, it goes down. So let's use that form in order to just find the vertex of each of these quadratic functions. So remember that it is y equals a times x minus h all squared plus k. Now the thing that's a little confusing here is our vertex is just hk. So when you look at something like a, the h is just the number here. This minus is a part of our equation, and it's not the vertex. The only thing that's a part of the vertex is this number here, just the h. So it's 1 comma, and then k is whatever's added on, and because there's nothing added on, it's 0. For this next one here, remember it's just the number and then a 3, so 1, 3. Now when there's a plus here, it gets a little tricky because this plus is really x minus a negative 1, except we don't do all that because it looks really messy. So if you're really subtracting a negative, you're adding, so we make it simpler. But our vertex would be at negative 1, because remember it's just the number, and then 4. So the other thing to remember, or the thing if you're confused, is this is always the opposite. So if it's x plus 1, your vertex is at negative 1. If it's x minus 1 like this one, it's at positive 1. So this one over here, it's at negative 3, negative 14. Because remember, this is x minus a negative 3 that we really have here. So now let's go backwards. I'm going to give you a vertex, and you have to write a quadratic equation with it in there. So we are going to assume a equals 1 for all of these. So basically all we have to plug in is our h and our k. So if we have a negative 3 here and a positive 5, we have two negatives. So our equation should be y equals x plus 3 all squared plus 5. We can do the same thing with the next one. Remember, we're filling in the blank, so it's x minus the x in our point all squared plus our k value. So we would just write this as x minus 5 all squared. And then this last one, y equals x minus the x in my point, which is 7, all squared plus k. And if you add a negative 2, we like to just say that you're subtracting. So it would look like that. So now that you're kind of familiar with vertex form, let's graph something in vertex form. So easy things to pick out are which way it opens, if you have a max or a min, and your vertex. Your axis of symmetry comes along with that, and then we can find our x-intercepts just like we have in the past. So the first thing to notice is that this is negative, so that means it's going to open down. So it's going to look like this, which means I am going to have a maximum. So I'm going to have this point right here. And that maximum, remember, is your vertex. So pick out your vertex. Remember, it's always opposite of what's in here, so it's at positive 5, positive 9. And then we can make a graph over 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 6, 7, 8, 9. And we know it's got to go down from here, so that's good that our graph kind of ends. Remember, from back here, the axis of symmetry is this h value here. Or you can remember that your vertex is on your axis of symmetry. So my axis of symmetry has to be x equals 5. So we know if we fold it right there, we're going to get the same thing on both sides. Now the next thing we have to do is our x-intercepts, and this is going to take a little work. But remember, when something crosses the x-axis, that means y is 0. So we're going to go up to our equation, and we're going to plug in 0 for y. And then we can solve this. So we got to subtract 9 from both sides. Remember, this is like a -1 out here, if that helps. And we got to divide by that -1. So we get 9 equals x minus 5 all squared. And if we want to solve this, all we got to do is take the square root of both sides. So remember, this gives you positive 3 equals x minus 5 and negative 3 equals x minus 5. You can add 5 to both. So we get x equals 8. Add 5 to both. We get x equals 2. So those are our two intercepts at 8, 0 and 2, 0. So 1, 2, and 8. And then that's really all we need. We know it opens down. We know the axis of symmetry. So if we find a point, we can find its matching point on the other side. And there's our graph. So some people like this way better than the intercepts that we did, but sometimes you have to use this way because not everything is factorable. So now that we know how to find the vertex, how to write an equation with the vertex, and how to graph it, we're going to learn how to convert something into vertex form. So in order to convert something from standard form into vertex form, we have to complete the square. Because if you notice in both of these, this one that we didn't do and this one here, we have a perfect square in here, and that's how it's in vertex form. So that's what we need to do with this. So remember, to complete the square, you first want to move over whatever value you have that doesn't make a perfect square. And then you want to save yourself some space. We're going to add something to both sides. And you want to factor this into a perfect square. So you want two numbers that add to make 16. And remember, they have to be the same two numbers. So they got to be 8 and 8. And then you multiply them together to get 64. And whatever you add to one side, you got to add to the other. Now this right side can be factored into x plus 8 squared. That's what those two 8's helped us decide. And this equals 64 plus y minus 71. So we're going to rewrite this as y minus 7. Now remember, when we're going to get something into any form, it's always y equals. So we got to move this 7 over, and we have y equals x plus 8 all squared plus 7, and it's in vertex form. So now if I asked you, it's really easy to find the vertex. It's going to be at -8 and positive 7. So let's do the same thing with this next one. First thing you got to do is move over the number that's not a perfect square. Save yourself some space because you're going to add something to both sides. And remember, you want to factor this. You want two things that add to make -2 that are exactly the same. So -1 and -1. Remember, you got to complete the square, so you got to multiply them together and you get +1. Whatever you add to one side, you got to add to the other. So this gives us y plus 6 over here. And remember, this side can be factored. The x minus 1's that we found there, and there's 2 of them. And then, in order to make it y equals, all I got to do is subtract 6 from both sides. So we get y equals x minus 1 all squared minus 6. So then from here, our vertex is 1, -6. And we're done. So let's do one more together. And these ones are weird because they have that number out front. So the first step is exactly the same. We're going to add 59 to both sides. So we get y plus 59 equals, this is a negative 1x squared minus 14x. And if you remember, you cannot complete the square with a number out front. So what we're going to do is factor this number out. And then we're just going to complete the square with this other stuff. Now the part that gets tricky here is when we go to factor this, and we want our two numbers that add to make 14, so there's 7 and 7. What we really have on this side, if we distribute this negative 1 back out, is a negative 49. So when I go to add this over here, I have to add a negative 49. The negative 1 is going to stay out front, and we're going to complete the square in here. So when we add these up, we get y plus 10. And then if we subtract 10 from both sides, we end up with this. So let's do this last one together, just because I know this is weird. So subtract 170 from both sides. You get y minus 170, and that equals 2x squared plus 36x. But remember, you can't have that 2 there. So what we have to do is factor it out. And then fill in the blanks. So we want two numbers. They got to add to make 18, and they have to be exactly the same, so 9 and 9. And then we add that to both sides. Now remember, this is really 2 times 81 here. So when we go to add something on this other side, we have to add 162, because that's what we really added over here. So you ended up with y minus 8 equals 2 times this thing factored is x plus 9 all squared. So you get y equals 2 times x plus 9 all squared plus 8. So I saved one for you to do, to convert it to vertex form and then graph it. If you would like, you can go back and do this one as well, and I can show you how to do that in class. Make sure you write down any questions you have, and we can go over them together in class. Enjoy your night.